So our learning intention is to study the effect of catalysts on the rate of reaction, including their nature, and to discuss theories of catalysis that exist. So in this video we're going to look at catalysts and how they affect the rate of a reaction. So to begin, it's important to know the definition of a catalyst, and a catalyst is a substance that alters the rate of the reaction without being consumed in that reaction. And when we're looking at catalysts, we're going to look at 4 different sections. We're going to look at the properties of catalysts, types of catalysts that exist, catalytic converters, and mechanisms of catalysts. So let's look at properties of catalysts to start. So as we can see here along the side, I've developed a diagram showing the properties of a catalyst. And when we have a reaction, catalysts are recovered chemically unchanged at the end of the reaction. And as we can see here on the right hand side, I have enzymes. And an enzyme is a substance that is produced by living things, and it can act as a biological catalyst. Now, catalysts tend to be very specific. So as we can see here in my diagram, the substrate goes into the enzyme to give us step 2. And once the reaction happens, it leaves the enzyme and forms our products, with our enzyme left ready to go for the next reaction to happen. However, any sort of change in this area here called the active site of your enzyme, if there's any change in the active site, it means that your substrate won't slot in perfectly, the reaction won't happen, and you won't produce your products. So when we say catalyst tends to be specific, we mean a change in active site can deem the enzyme useless. Now, catalysts don't need to be present in large amounts. We only need small amounts of them, as they are only there to alter the rate of the reaction. Now, catalysts help equilibrium be achieved quickly, but they do not shift the position of the equilibrium. They only help it to get there quicker. And as I've said, if the active site of our catalyst or enzyme changes shape, then we say that the catalyst has been destroyed, and it will have been destroyed by a substance called catalytic poison. Next, we'll move on to types of catalysts. Now, there's 3 types of catalysts that we're going to go through. So the first one is homogeneous catalysis. Now, homogeneous catalysis is catalysis in which both the reactant and the catalyst are in the same phase. So that means there is no boundary between the reactant and the catalyst. Now, phase, this is a new word for us. So to simplify it and explain what a phase just basically means a solid, liquid, or gas. So it's another phrase that can be used to talk about the state of matter of your reactant and your catalyst. So just to summarize, a homogeneous catalysis occurs when both the reactant and the catalyst are in the same phase, i.e. they are both solids, both liquids, or both gases. The second type of catalysis that we're going to look at is heterogeneous catalysis. And heterogeneous catalysis is catalysis in which the reactant and catalyst are both in different phases. So that means there is no boundary between the reactants and the catalyst. So for example, your reactant could be a solid, so that must mean your catalyst is either a liquid or a gas. Now, we have seen this before in our earlier videos on rates of reaction, and this was in the production of oxygen experiment. This was heterogeneous catalysis, where we had our solid catalyst, which was manganese dioxide, and our reactant liquid, which was hydrogen peroxide. The third and final type of catalysis that we will look at is autocatalysis. And autocatalysis is when one of the products of your reaction acts as a catalyst for the reaction. So that would basically mean that once your first piece of product is formed, that the reaction would speed up or slow down because the product would be acting as a catalyst. And we see this in some of our titrations that we do on our chemistry course, and it is mainly seen in university laboratories to help speed up chemical reactions. So the next section that we want to look at is catalytic converters. Now, catalytic converters, you would commonly know that catalytic converters can be found in cars. So what do they do? Catalytic converters are devices that contain catalysts which convert harmful substances into non-harmful substances. And they are commonly fitted to the exhaust system of a car to convert pollutants into gases such as nitrogen and oxygen. However, catalytic converters can be broken, as we've said already, by catalytic poisons. And a catalytic poison is a substance that will make a catalyst inactive. And we discussed that when we were talking about our active site changing shape in our enzymes. This diagram here explains how catalytic converters work. So as we can see in the main part of our catalytic converter, we have ceramic honeycomb shaped inlets that are covered with catalysts such as platinum, palladium and rhodium. And into our catalytic converter goes our harmful substances such as carbon monoxide, nitrogen monoxide, nitrogen dioxide and hydrocarbons. They pass through the catalytic converter where they react on the surface of these honeycomb inlets with the platinum, palladium or rhodium catalyst, and that causes then water, nitrogen or carbon dioxide to be released out of our catalytic converter. And these products that come out of our catalytic converter are far better for the environment than the substances that go into it. So without catalytic converters in cars would be even worse for the environment than they already are. The final section on catalysis that we want to explore is mechanisms of catalysis, and there's two general mechanisms that we need to know. We need to know the intermediate formation theory, and we need to know the surface absorption theory. So let's begin with the intermediate formation theory. Now, the intermediate formation theory was suggested by Arrhenius, and he believed that catalysts worked by forming intermediate compounds during reactions, hence the name intermediate formation theory. Now, Arrhenius believed that these intermediates only existed for a very short period of time, and as a result were very difficult to detect. So let's look at an example now of Arrhenius's idea. So if we start here with our reactant, which is W, and reacted with a catalyst, Arrhenius believed that this went to form an intermediate called WC, and that this intermediate then reacted with our other reactant in the reaction to produce our two products and the catalyst, which has been regenerated here. So to put that in short, we would say that the two reactants react to give our two products, and the catalyst is reproduced for use in the next reaction. The second mechanism of catalysis that we look at in the Leaving Cert course is surface adsorption theory. Now, we've already met the word adsorption in our chromatography, and if we remember correctly, it means to stick onto something. So surface adsorption theory mostly occurs in a heterogeneous catalysis reaction. And if you remember from earlier in the video, we said that heterogeneous catalysis is when your reactant and your catalyst are in different phases. So adsorption, as I've said already, is the sticking of a substance onto the surface of another substance. So here, for example, we would have hydrogen and oxygen reacting to produce water through the use of a platinum catalyst. So here we would say that the hydrogen and oxygen molecules settle onto the surface of the platinum catalyst, and they are held there by temporary bonds. So the oxygen and hydrogen molecules then react with each other to form water on the surface of the platinum to give us our reaction that we have already seen. Now, once the water is formed on the surface of our platinum catalyst, we can then say that the water undergoes desorption and the product leaves the surface of the catalyst and is collected. So here, our platinum catalyst is basically being used as a surface for our reactants to stick onto to react to form our product. That's it for this video. Have a read over the learning intentions to make sure you understand everything we've gone through.